Hello everyone, we are at Beyond the Formula. Let us see what is electromotive force or EMF and terminal voltage or terminal potential difference. So have you noticed that if I have a cell or a battery, if I have a cell or battery rated as 1.5 volts, 1.5 volts, it it do not give always exactly 5 volts. If I connect it across a bulb, it do not give exactly 5 volts or 1.5 volts, right? It gives a little less, say 1.3, 1.2 volts. So why does the voltage drop? Why does the voltage drop? Why does the voltage drops? Right? The written, what is written in that? If I have this cell or a battery, it is written as EMF is equals to 1.5 volts, right? 1.5 volts. But if I connect multimeter over here, if I connect voltmeter or multimeter, it reads what? This value 1.3 to 1.2 volts. So why does the voltage drop? Let's see. Here we have EMF. What is EMF? Electromotive force. Electromotive force. Now it is not actually a force. EMF, it is not actually a force. It is not actually a force. It is the energy supplied by the cell per unit charge. Now what is this definition? It says that EMF E is equals to energy supplied W per unit charge. That is, if I connect a cell or battery and if I have a load, say this is some load, can be a bulb, can be anything else. So if I have this battery of voltage B, now what happens? This load will allow current to pass through it, right? Now this will demand charge. This load will demand charge, as flow of current is what? Nothing but flow of charge dq over dt. I equals dq over dt. So per unit charge, for a single unit of charge, the amount of energy required or given by the cell is called what? Electromotive force or EMF. Now if I say there is no current, I equals to 0. Now if there is no current drawn, no energy is lost. No energy is required to what? To transfer current equals to 0. If current is 0, then no energy is required, and hence the voltage is called EMF or electromotive force. Now what happens inside the battery? inside the battery, if current passes or flows I, it has charges. Inside the battery there are charges, right, which flows. If I say electrons flows from negative terminal to positive terminal, right, and positive charges flows from positive to negative terminals. So what happens here? Collision. What happens? Collision between charges. Now this collision creates heat and energy loss, which we termed as what? Internal resistance of battery. So what happens? We can consider the cell as this. Now this is the ideal, non-ideal, or real battery or cell. So this is ES, EMF, and RS, internal resistance. Now what happens here? If I connect this cell across a bulb or another resistance, current will flow I, correct? If this has a EMF of E and internal resistance is R, and let's say the resistance of bulb is capital R, so we know what this capital R and small r in series, so we have I equals to electromotive force E over IR plus electromotive force E over R plus R, correct? Now what is the drop? Here? What is the drop here on the bulb? I times R. So what is drop? V over R is I times R, which is equals to EI upon over R plus R, right? So this is the same potential here. This is the same potential V, correct? Which the voltmeter will measure, correct? So we know that here V of R is equals E minus IR, correct? E minus IR. So we have V is what? This is what? Terminal potential difference. The potential difference measured across the terminal. VT is what? Terminal potential difference that is measured across battery when load condition applied, right? So we have VT, that is equals to what? That it equals to the voltage drop across bulb or capital resistance R. So we have VT equals E, that is EMF, minus I times R. That is why what? The VT, terminal potential difference, is less than EMF. So we have VT less than E. So when I equals 0 in the circuit, that is open circuit condition. Open circuit condition, Vt becomes E. Terminal voltage or terminal potential becomes equals to the EMF. And when charging, another case, when charging, the current flows in the circuit in opposite direction. When charging, if I charge this battery with another source, if I charge this battery with another source, the current flows in opposite direction. So here we have terminal potential difference, Vt equals E plus IR. So here Vt is greater than E. Correct? Thanks.